Okay, so we're to the Module 2 skills test, and this is going to be about the radiation budget. And so you're given a website that we need to go to. It's the Earth System Research Laboratory, ESRL. And if you go to this website, you get a chance to choose a particular location. One's in Illinois, in Montana, Mississippi, Sioux Falls, South Dakota. Just, it doesn't matter which one. You just choose any of them just by clicking the radio button. And then you have to choose some variables. We're going to use the most recent data, and then we're going to choose some variables to plot. Those include downwelling solar, downwelling infrared, and upwelling infrared. Nothing else should be checked. And go ahead and plot your data. And you'll wind up with a graph that looks like this. First thing you need to do now is to, again, right-click. For PC users, Mac users may have another way of doing this, and save image as. Again, save this to a location on your computer that you can easily find again, because this you need to upload. I'll be looking at your data and seeing how you answer using your data. So it's very important you upload a file, and that's what I'm going to be using then to compare against your answers to see if you're able to do all the calculations correctly. So then moving on down, the next thing you need to figure out is the time. Now notice that here we have the hour of day on the bottom line, UTC, that's Universal Time Coordinates. Okay, so that's Greenwich Mean Time, or Zulu time. And there is a local time up here, but this is local standard time, so you'll need to take that into consideration. You may not want to use these numbers because it doesn't take into account daylight savings time. So your best bet is to figure out what local noon should be for your location. Again, in this case I'm in Goodwin Creek, Mississippi. Figure out which time zone that's going to be. Illinois, Colorado, Pennsylvania. Whichever station you're using, make sure you know which time zone it's in. Make sure you know whether it's in standard or daylight time, and then figure out what midnight local is in UTC, and what it is in Zulu time. Likewise, for noontime, when it is local noon, what is the time in UTC? That's what you need to report as your answer to question number 2. Then the rest of it is pretty straightforward. You just have to look at the graph and figure out what the radiation budget is. You're given an equation as to how to figure out what the radiation budget is. And you'll be using, again, you'll have to read the values on the left side of this graph. These are all in watts per square meter. So it's essentially the amount of area per, the amount of energy per area at the surface of the Earth from these 3 sources, from downwelling solar, from downwelling infrared, the blue line, and from upwelling infrared. So you've got to use those values, and you'll just kind of read those values at midnight and at noon by looking at the scale. And you have to kind of just use the scale and figure out what the values are, and then plug them into the equation and figure out whether you've got a surplus or whether you've got a lack of energy, and that will have an effect on whether the temperature at the surface would be climbing or if it would be falling at that time of the day. But other than that, this is pretty straightforward, so it shouldn't take too long to do these calculations, but it is useful to get a feel for how the radiation budget changes during the course of the day, and perhaps even during the course of the year. You might get different results if you're taking this course in the springtime compared to in the fall. So it should be a fairly interesting little exercise.